used angle-angle similarity. Because two angles, what does that imply? Angle, angle, angle. Does that make sense, everybody?
Yes.
So yes, they are similar because two of them are. So if these two triangles right here, if these two triangles are similar, can someone give me the statement of proportionality? Amanda, what's the statement of proportionality? RS, I'll start you off. RS is to? Yep. QT, yeah. Equals? RQ. Yep. RQ over, what's that correspond to on the other one? I'm pointing to it right here. RT, yeah, you got it. You got it right there. It's fine. So let's fill this in and see what it gives us. What is RT? 25. Do we know RQ? Yeah, what is RQ? It tells us that's 15. Do we know what SQ is? Do we know what QT is? Yeah, exactly. I hope maybe it'll just give it to you. It's like, can you read the diagram? No, you need to figure it out in this case. What is QT? What? 20. Thank you. And actually, do we need to go any further? No. Divide 25 times SQ is equal to 20 times. Divide everything by 5. I cross-multiplied.
Oh.
5 SQ is equal to, divided by 5, 4 times. We can only divide one of them. So now by 5 again, and you get SQ is equal to 4 times, which is 12. Does that make sense? From our similarity relationship, we generated a similarity proportion, and from that proportion, we filled in the blanks, all besides SQ, and then we just solved the ratio. Yes, Lynn. This fraction right here on the left, that's the same as A over B plus B over B is equal to M over N plus. What's B over B?
1. Oh, it's good.
Over. What can you subtract from both sides?
1.
So you end up with A over B plus, oh, equals what?
M over N.
A over B equals M over N. Yep. There it is. That one's okay. Let's try this one right here. What changed about that?
They switched all the values.
Yeah, they switched both sides. Can you do that? Yes.
Why can you do that?
Because if 1 over 3 is equal to 7 over 21, when you switch it, it's the same. It's the same operation on both sides. Or you can think about it this way. You ready, Dixon? Are you allowed to, if you wanted to, switch these two?
Yeah.
Could you switch these two?
Yep. Oh, so you can just switch all.
You end up with 21 over 3. 21 over 7 is equal to 3 over 1. Is that the same thing?
Yep.
Cool?
Yep. So
Nice.
B.
So it's what?
B.
B. Yay. And you get to fill it in completely with a number 2 pencil. Not quite. Which pair do you want to check if C isn't the answer? Which one? B. 16 and 256. 16 times 256. And we do the second square root of the answer. And what do we get? 64. So in this case, what is the answer? B. Similarity thing doesn't work. Sometimes. Crowdsourcing doesn't always work. There are common misconceptions. As a side note, and I'll even put this into the recorded notes, there's a great thing you can look up, which is there's a great page everybody should read. How many people have read this? The common misconception page on Wikipedia. This is fantastic. Read this, and you will learn more than I could ever teach you about like the world right here. There are a lot. You know what a common misconception? What that means? It's something that a lot of people believe that is wrong. Like, for example, can you see the Great Wall of China in space?
Can you?
No, you can't. It's a very common misconception. So read this tonight.
But if it's Wikipedia, Wikipedia has lots of wrong.
Over ML is equal to LJ over, which is equal to KJ over MN. So do you know a lot of these? Sure. What's KL?
19.
What's ML?
16.
What's LJ? We don't know. What's LN?
18.
Oh, we do know that. What's KJ? And what's MN? Don't know. What are we looking for? JN. We're looking for that one, right? So we know that 18. It's not working. 18 times. Being uncooperative. 18 times 19 is equal to 16 times question mark. So question mark is equal to 18 times 19 over 16. 9 times 19 over 8. You can do that out. We good? Which one is it going to be? 9 times 19 divided by 8. Math to fraction. Ooh, is that one of the answers?
Oh, you can give it fractions?
Is that one of the answers?
No.
No, so did we do something wrong?
Simplify. Yeah. You didn't.
What's wrong?
You solve for something that's not KN.
What did we solve for? We just solved for LJ. We just solved for this one right here. What do we actually want?
NJ.
We want JN.
So can you add KM and JN?
Hold on. We want JN. We want that right there, right? So we just got the whole thing. What do we need to subtract from it? Exactly. So we want to do 9 times 19 over 8 minus what? Equals. So what do we subtract? Minus 18.
Yes.
And is that correct?
Wait, how do you get fractions on your calculator?
Hit the math button, and then you have a button that says to fraction.
Oh, okay.
Boom. It worked. So what's our answer?
B.
B.
Does it simplify it for you?
Yes. Yes.
For number 8?
Yep. Plus 3 root 5 minus root 5. How many 5s do you see?
8. 5.
2 of them, 3 of them, and minus 1 of them. How many do you have? 4 of them.
How do you have 4?
If you have 2 apples and 3 apples and you take away 1 apple, how many apples do you have? If you have 2 apples and add 3 apples to it and then take away 1, how many apples do you have? 2 root 5 plus 3 root 5 minus root 5 is equal to 4 root 5. Ready? 2 ponies plus 3 ponies minus a pony. How many ponies do we have? This is a really...
You still have the numbers, you still have the 5 in there.
Yeah, in this case, root 5 is a pony.
What are the other numbers?
What are the other numbers where?
The 2 and the 3?
Yeah, there are 2 of them here, 3 of them here. What's 2x plus 3x minus x?
4.
Exactly. So what's 2 root 5 plus 3 root 5 minus root 5? 4 root. Yes.
How do you do it if you have, like, what if one of them is root 4? How would you do it?
So if it's different root 7, for example, you can't. They have to stay separate. In this case, are they setting you up to have the same ones in each case?
Yes.
Yeah, they are. They're specifically setting you up so these simplify nicely. They're specifically setting you up so they do nicely. So someone pick another one that they couldn't figure out. Once you get the hang of this, it goes really quickly. I understand that. Anyone in particular?
14.
14? Sure, 14. No, but let's do 14. That is not one we're supposed to. We're supposed to do multiples of 3. And it'd be a lot harder if you did all of them. So 50. The best way you can go about this, you're looking for square factors. Sometimes they're hard to find. What you want to do is take out the This is what I do. I make factor trees. Watch this. This is what I do. I do this to this day. I will do this. What's the easiest number to take out of 50? 2. What's left? What can you take out of 25? What's left? So what factors are the factors are 2, 5, and 5. So what's a square factor? 25. So root 50 is the same thing as 25 times 2. What about 18? What can you? We're not done yet. What can you take out of 18? 2 and 9. What's 9? 3 and 3. So this is 2 times 3 times 3. So that's the square root of 9 times the square root of 2. And I'm not putting another one in there. So what does that turn into? The square root of 25 times the square root of 2 minus the square root of 9 times the square root of 2. What's the square root of 25? 5 root 2 minus 3 root 2 is equal to?
2 root 2.
Yeah!
Yeah.
Cool?
The outside is telling how many the inside
Yeah.
have.
Yes! 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 Woo!
They're probably
We don't like radicals in the denominator. What's the only thing you can multiply by and have the same number? 1. You can only multiply by 1 and it doesn't change. Let's simplify root 12 though. What is 12? Exactly, so it's the square root of 4 times the square root of 3, which is 4 over 2 root 3. What's that become? 2 over root 3. One more thing you can do to simplify this. I still don't like having a radical in the denominator. What could I multiply this by? 2 over the square root of 3. That's a form of 1, so it's the same thing on the top and the bottom. That would get rid of the root 3. Yeah, root 3 over root 3. What do you end up on top? What do you end up on bottom? 3. This is really important. The square root of 5 times the square root of 5 is 5. The square root of 6 times the square root of 6 is?
6.
The square root of negative 5 times the square root of negative 5 is?
5.
Say it again. The square root of 2 times the square root of 2 is? 2. The square root of 3 times the square root of 3 is?
3.
The square root of a table times the square root of a table is? A table. The square root of negative 5 times the square root of negative 5 is? Negative 5.
It's like an imaginary number.
That's original. The square root of negative 5 is an imaginary number, but if you multiply the square root of negative 5 times the square root of negative 5, you end up with, which is not an imaginary number.
Gotcha.
Sometimes, here's something deep for you. Sometimes when you multiply two imaginary numbers, you end up with a
Imaginary number.
what? A real number.
You can get a positive.
You could get a positive real number, or you could get a positive imaginary number. Ooh, your brain hurt?
I got a brainificate.
Okay. And the same rules still apply, but are we done? Not really. I don't really like that root 5 in the denominator. So what am I going to multiply by, Tony?
3.
Nope.
No, 5.
Root 5 over,
Root 5.
because when I do that out, what's the denominator become?
5.
5 over root what?
3 times root 5.
Which root 3 times root 5, which is root what?
15.
Put it back together. It's totally debatable which one is cleaner. Which one do you think is cleaner, that or this?
That one. The second one.
The second one?
Because you get rid of one of them.
Yeah, that's what people would say. It's only one radical, right? But it's a bigger number, right?
Yeah.
It's debatable. Hammer, which one?
Number 15 on the table.
This one right here? 15?
Gonna get to it first.
Okay, so those are interesting numbers. So we want to simplify this. 64. What's the square root of 64?
8.
8. So this is 8 minus, well, this is root. Let's break 28 down.
Root 7.
2 times 14. 2 times 2 times 7. So it's root 4 times root. So it's 8 minus what? 2 root 7. Can you go any further than that? Can you go any further?
It's debatable.
And you could type it into your calculator and press enter and call that going further, right?
Yeah.
No, but there's no. Are there any radicals we can? No, there's nothing else there we can do. Sometimes the answer is going to be a constant and a radical. Absolutely.